first speakers here. So without any further ado, I'd like to introduce Jim Hamill with Hamill Geotechnical Consultants. He is going to speak about visual observation and monitoring of landslides. Jim, please.
Okay, thank you, Dan. Well, good morning, everybody. Today, I'm going to tell you a little bit about visual observation and monitoring of landslides. The late Ralph Peck, one of the giants of geotechnical engineering, pioneered the observational method in geotechnical engineering. He left us a lot of words of wisdom. And for students and young professionals, you would do well to study his life and read his publications. The words that he had in a 1972 paper are appropriate to our topic today. Peck wrote, "An instrument too often overlooked in our technical world is a human eye connected to the brain of an intelligent human being. It can detect most of what we need to know about subsurface construction. Only when the eye cannot directly obtain the necessary data is there a need to supplement it by more specialized instruments." You'll be hearing a lot about more sophisticated instrumentation and monitoring in other seminar presentations. Here, I'm going to give you the introductory low-key version of landslide monitoring. Many landslide problems here in southwestern Pennsylvania and elsewhere involve reactivation of old marginally stable landslides. Landslide reactivation, like initiation of new slides, usually begins slowly and is always accompanied by indicators. For example, ground cracks, bulges, depressions, loosening, swallowing, raveling of soil and rock, and water discharge. These indicators can be visually observed and monitored. This is what you do when you walk around and look at a landslide site. You use your observational skills plus what you learned in school. For example, civil engineers use material behavior, structural behavior, geotechnical, hydraulic engineering. Geologists use physical geology, geomorphology, structural geology, field mapping concepts. Cracks are the typical indicators of landslide reactivation or landslide development. In early March of 1969, I was driving my classic 1967 Volvo sedan up this haul road when I-79 was being constructed west of Pittsburgh. This I-79 site is the first one I talked about last week in the student seminar. As I was driving along, I noticed cracks opening up in the natural slope above the haul road. I stopped my car and jumped out. I couldn't wait too long because there were trucks zooming up and down the road. But I also noticed, where's my cursor? I also noticed a crack beginning to form in the haul road left of the car here. This is what the crack looked like 2.5 months later. Several inches wide, several feet deep, slick and sided red clay stone, in it, yellow pencil for scale. Visual observation and monitoring is particularly important in the early stages of slide reactivation or new slide development in order to characterize type, extent, and velocity of slide movement, assess risk to structures, utilities, and people, and plan slide responses, including risk reduction measures. All of this before any subsurface exploration is done or any instrumentation is installed. We'll start out with a simple example. This is a small sewage treatment plant in a rural area in southwestern Pennsylvania. An earth flow is coming down the slope onto the chain link fence around the plant site. The earth flow is deforming the fence and mud is oozing through the fence onto the lawn. Here we can visually observe and monitor landslide behavior via the fence and the mud while we buy time living with the landslide and seeking funding to repair the landslide. Many landslides have to be lived with, particularly in older residential areas in the Pittsburgh area. So you learn to live with them and keep an eye on them. Now let's look at a more significant landslide. This slide occurred on the West End slope below the West End overlook 15 years ago. You can see downtown Pittsburgh in the background, the West End Bridge here. The end of this road is breaking off, falling down slope, knocking off boulders in the slope. All this debris is going down on the Norfolk Southern Railroad at the toe of the slope. Trains have to slow down, in many cases stop for debris to be removed from the road or the railroad. Over here we see water coming down the road into the slide area. Whoop. Another view of it on the right. And this is what we see when we go back up the road to look for the water. It's always important to observe and monitor water sources, water flow paths, document them with photos, notes, etc. In this particular case, the water is coming down the slope from the West End overlook area, coming across the edge of this yard into the street, and flowing down the street into the slide area that we were looking at previously from the other end. The low-tech 6-foot folding engineer's rule is one of our key monitoring tools. Here it's folded 3 feet by 3 feet to make an arrow showing the water flow direction. We can observe and monitor landslide scarp heights. This is a scarp that formed along the outer edge of the road. The slide area we looked at previously is up at the end of the road here. Measuring the height of scarp over time indicates whether the slide is developing further or perhaps stabilizing. We will look at these houses a little later. It's always important to observe and monitor ground crack widths. You can set up monitoring points like a fence corner. Measure the width and depth of cracks over time. Here you see the 10th side of my engineer's rule. Yeah. The 10th side always shows up better than the inches side. You also see a colored wood pencil. These are useful pointers in photographs, and they're less expensive than mechanical pencils when you lose them in the field. I know because I've lost an awful lot of pencils, both wood and mechanical, in the field over the last 50 years. This is a concrete parking pad adjacent to one of the houses. The joints between the slabs are starting to open up. Here you see the inches side of my engineer's rule. I think you'll agree it doesn't show up as well as the 10th side. We can observe and monitor asphalt cracks, again, width and depth. Keep track of these with notes, photos. It's also important to observe and monitor structure cracks. This is one of the houses along the street, behind that scarp I showed you previously. The front porch is pulling away from the front wall of the house. You have to look at all the structures in the vicinity. This is the next house down the street. We're looking at the opposite side of it from the porch that we were looking at previously. This house has an add-on, sort of a sun porch or informal greenhouse here stuck on the front corner. That porch is pulling away also. These observations give us concerns about safety of the houses and their inhabitants. On the left here is a view of the slope behind the houses. One of the houses here, there's a rock ledge, an old landslide scarp in the slope, icicles formed on this ledge. This water comes from surface runoff and groundwater discharge from upslope. The hummocky soil in front of the old scarp is colluvium, or old landslide debris. The lower part of it was excavated to make the backyards for these houses. You have to go up and walk all along the scarp looking for things of interest. You get over here past the icicles and you find that the colluvial soil is beginning to pull away from the scarp. This is a 3 foot by 3 foot rule for scale. You go a little further down the scarp and you find that the siltstone underneath this sandstone ledge, the siltstone is starting to spall, crack, and loosen up. Well, when the rock in the old slide scarp begins to spall like this, it's definitely time to evacuate the houses and turn off the utilities. The late Yogi Berra was one of my favorite philosophers. As many of you know, he was a Hall of Fame catcher with the New York Yankees from the late 1940s to the mid-1960s, led them to several World Series championships during that time, and he's noted for his quotations. Perhaps his most famous quotation is, "It ain't over till it's over." But he had another quotation that I want to leave you with because it's more appropriate to our topic today. You can observe a lot by just watching. Thank you for your attention. Are there any questions? Dan, what do I do? Exit this share screen now?
We can hold off a little bit just so if you want to refer to a slide, it might be useful.
Okay.
There are no questions that have come in yet. Do people have questions? Okay, here's the
I can
first
deal
question.
with no questions.
Here's the first question.
Oh.
This question says, I'm curious how emerging technology like drones are used in this field. Do you have any insight there?
Well, yes, they're used a lot now. 15 years ago, I don't think we had drones, or if we did, they were experimental. Okay. Many of the later seminar presentations, I think some in this breakout session and certainly some in other sessions, we'll talk about drones. I'm starting out with the old-fashioned boots on the ground introductory stuff here.
Yep.
Perhaps to prepare people for the things that will come when we get to the high-tech stuff.
Agreed.
Any other questions?
I have a question. Have you ever seen anyone who's sort of comprehensively gone around after a cold snap and just sort of mapped the springs across hillsides in Pittsburgh, sort of like that the scar you were showing with all the icicles?
I don't know if anyone who's done this, because nobody would pay you to do this.
Right.
From a research standpoint, you might be able to get students to do it, if you
Right.
mobilized them at the right time of year.
Right.
But I don't know of anyone who's done it. Certainly the icicles are good visual indicators of water discharge. Some slopes are wetter than others. The icicles on this particular slope, I would say that's kind of in the medium range of icicles on slopes. I've seen some that are much, much more heavily iced, and some that only have minimal icicles in the winter.
Okay. Here's another question that just came in. It says, how often would you typically, or do you, it says, how often do you have to inspect a potential landslide area?
Oh, it kind of depends on how big it is, how active it is, and what it's threatening. In the case of the sewage treatment plant that I showed you initially with the chain link fence, inspecting it about once a week is probably sufficient. In the case of this street that was cracking up and the houses cracking up, I was out there every day during the critical period, typically 10, 12 hours a day watching it. I also had to watch things down below on the railroad, so I was up and down between the railroad and the street.
Other questions?
Hey, Jim, I'll chime in with a question if I can.
Sure.
So can you touch a little bit on seasonal and weather effects on landslides?
Well, yes. Late winter, early spring is the landslide season. You see it on the news, you see it on TV. That's when snow melts and rain comes. If we have a severe winter, we get a lot of freeze thaw. We get the icicles holding the water in the slopes. Then things begin to melt and the slides and rock falls occur. We do, however, have landslides any time of year. This landslide I showed you below the west end began in 2004, which was the second wettest year on record in Pittsburgh. I think 2018 surpassed it as the wettest year. But this slide had actually started before the two hurricanes, Francis and Ivan, in September of that year. This slide had started around March or so. The extreme precipitation in September 2004 exacerbated the slide. These heavy precipitation events can occur anytime, spring, summer, fall, hurricane season. That was a wide-ranging answer, Brian, but I guess we're trying to use up our time here.
Oh, that was fine, Jim. That's exactly what I was looking for, just seasonal fluctuations, just for the benefit of the students.
Here's the question just came in. For those who are evacuated from their homes, did they return, or were the houses determined to be unsafe forever, indefinitely?
When things were cracking up in the siltstone of the backscarp, I recommended they leave that night and go live with relatives or in motels or someplace. They did. They left all their belongings. They came back over the next week or two and moved out their belongings. The city of Pittsburgh deemed the houses uninhabitable, unsafe. The utilities were turned off. The city eventually purchased the houses and demolished them. If you go out there now, it's a regraded hillside with no houses.
All right, we have time for one last question, then we should probably transition.
Okay.
Is there anybody that has a question?
I thought you actually had one last
Nope.
question.
I'm just calling for, I'm sorry, I'm calling for
Oh.
one last question. I misspoke. All right. How about this? I think we probably will have a little bit of swing time at the end of this session because the other sessions had more problems than we did. Thankfully for me, this has gone relatively smoothly. But why don't we move on to Brian Hensel, and then if there are questions at the end for Dr. Hamill, those of you who we can ask those at the end during some sort of mop-up time period. But thank you very much, Jim. That was really great, and just great images. I agree completely about looking and just walking those landslides. That's really important.